Now that we've learned the properties of atoms and the properties of specific chemical bonds, let's move on to learning about the periodic table of elements. For this class only, we're only going to learn about these two columns here and all of these columns here. These are our transitional metals, but we don't need to learn about them in our biology class. Right now, we're going to learn about the groups. So the groups are the columns. Columns go up and down. So for example, group 1 is found in this column. We have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. That makes up our group 1 elements, which are known as the alkali metals. The ones that I really want you to know that are in group 1 are sodium and potassium. For biology, those come up often. Some characteristics of these alkali metals is that they have one outer electron, and they also form +1 cations because they lose one electron when they react. And they are very reactive with the halogens, which we'll talk about here in a little bit. So remember, the group number also indicates the number of outer electrons as well as the number of cations in this particular case. In group 2, we have the alkaline earth metals. The ones that I want you to know are magnesium and calcium. Calcium is especially important when we talk about our bones. Some characteristics of these alkaline earth metals are that they have 2 outer electrons, which is indicated by their group number. Group 2, 2 outer electrons. These form +2 cations, and that's because they lose 2 electrons, meaning they have 2 extra protons. These will react with hydrogen, oxygen, and halogens, and in some cases water. Group 3 elements, known as the boron group, contain these elements. For our class, you don't need to know these by heart, but it's good to know that the group 3 elements form +3 cations because they lose 3 electrons. Our group 4, which I just called the carbon group, they have another name, but we don't need to worry about it. This is the one that I want you to know, is carbon. Carbon is one of the most important elements when we talk about life. Carbon has 4 electrons in its outer shell. Actually, all of these elements do. And they form covalent bonds, meaning that they share electrons rather than transfer. So there's going to be no overall charge when they share electrons. Group 5 elements, which I'm just calling the nitrogen group, contain all of these elements, but for our class, just know that the nitrogen and phosphorus are in this group. They have 5 outer electrons, and so for them, it's going to be easier to gain 3 electrons to obtain a full outer shell, and when they have a negative charge, remember, they're called anions. In group 6, which I'm calling the oxygen group, consists of these elements, and you just need to know that oxygen and sulfur are located in group 6. These have 6 electrons in the outer shell, and they will gain 2 electrons, forming a -2 anion. Oxygen and sulfur are electronegative, meaning that they love to take electrons. Group 7 are the halogens. The halogens are highly reactive. You don't need to know any of these except for chlorine for this class. And in group 7, here again, the group number and the number of valence electrons, we have 7 electrons in the outer shell. They're going to form a -1 anion because they're just going to gain 1 electron to get 8. Fluorine is the most electronegative element. All of these are strong oxidizing agents, meaning they love to gain electrons. And these guys generally react with group 1 elements. Group 8, which is our noble gases, are the elements that all other elements in the periodic table react to be like, because they have 8 electrons in their outer shell, and so they're stable. They're very, very non-reactive. And these are all the elements that are found and considered to be noble gases. Now that we've learned of things about atoms and about the periodic table, it's important to learn about matter, because matter makes up everything, and these atoms make up matter. So you're probably wondering, what is matter? Well, matter can be a solid, and the properties of a solid is that they have a definite shape and volume, they're rigid and cannot be easily compressed. So if you think about it and you try and take your desk and shove it into a cup, it's not going to happen because it's solid and very rigid. Solids do not diffuse into other solids easily, meaning it's going to take a lot of pressure to mix them into one. Heating a solid can turn it into a liquid. Think of ice. Ice is a solid that if you add heat, it's going to turn into liquid water. So here's a really good diagram that I recommend drawing. Solid, that they have definite shape and definite volume. Another type of phase of matter is liquids. Liquids have a definite volume, but they don't have a definite shape, and that's because they take on the shape of a container. So if you think of water and you poured it into a bowl, and then you poured it into a cup, and then you poured it on the floor, whatever you pour it onto, that is what it's going to take the shape of. Liquids are also compressible, meaning that you can squish them into a smaller space, and they can diffuse into another liquid. For example, if you take red food colored water and green food colored water and you mix them together, you would eventually get some kind of darkish, icky color. And if you heat a liquid enough, you're going to turn it into a gas. That's like when you boil water on a stove, you see the steam come out. That is the gaseous form of water. And here's another good diagram that I also recommend drawing, and that's shifting shape and definite volume. Those are two important properties of liquids. Another phase of matter are gases. The properties for gases is that they have no definite shape or volume, and that's because they'll take the shape of any container. If you think of the air that you're breathing right now, that is all gas. It has no surface of its own, and it's not rigid and can easily be compressed. So if you think of people who need to be on oxygen tanks, that is just the gaseous form of oxygen compressed into a canister, which makes it a liquid. Gas diffuses into other gases easily. For example, if you take a perfume and you spray it into the one corner of the room, it would be a matter of minutes before you could smell it on the complete opposite side of the room. Cooling gas turns it into a liquid, and we see this as water evaporates from the oceans and cool air rises, or hot air rises, and eventually it cools and we get precipitation, such as rain, snow, sleet, hail, etc. Gas flows in all directions and requires a closed vessel in order to keep it contained. Again, here's another good diagram showing two characteristics of gas, is that they have both shifting shape, meaning no shape, and no definite volume. These three things make up matter: solids, liquids, and gases. Matter is everything around you, and matter is anything made up of atoms and molecules. It is anything that has mass and takes up space. And that itself is a very important concept, so if I were you, I would probably write that down. To change states of matter, we need to add or remove energy in the form of heat. For example, heating a solid turns it into a liquid, and heating a liquid turns it into gas. Whereas cooling a gas turns it into a liquid, and if I cool a liquid, I'm going to turn it into a solid. Here, we removed energy, such as heat, and turned water into ice. So on the left, I have a cup of ice that I cooled and I removed heat energy, and here I have my ice on the right. So just a quick review, we discussed parts of an atom, and in the nucleus of the atom we have our protons, which have a positive charge, and our neutrons, which are neutral, they have no charge. Outside of the nucleus, orbiting outside the nucleus, are our electrons, and they have a negative charge. Remember, electrons are responsible for all chemical reactions. Chemical bonds, or chemical reactions, can be covalent, which is sharing electrons, and ionic, which is transferring electrons. These ionic bonds can form ionic solids, for example, salt. The sodium ion comes together with the chloride ion and they form salt. That is an ionic solid. Then we discussed the periodic table of elements. And the groups, remember, are the columns, which are up and down. And the group number can tell you the number of electrons in the valence electron, or in the valence shell. Group 1 elements form a +1 cation. Group 2 forms a +2 cation. Group 3 forms a +3 cation, whereas group 4, remember that's our carbon group, forms covalent bonds. It has no anion or cation. Group 5 forms a -3 anion, Group 6 forms a -2 anion, and Group 7 forms a -1 anion. Remember, anions are formed by the gain of electron, whereas cations are formed by the loss of electrons. All of these electrons want to be like the noble gases. And remember, noble gases are found in group 8, and they do not react because they have full valence electron shells. Then finally we discussed matter. Matter is anything that has volume and takes up space. And the phases of matter that we talked about are solids, liquids, and gases. And all of this matter is made up of atoms. Thank you for tuning in to this tutorial on properties of atoms and properties of matter.